Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Assalamu alaikum little kids. Today we are going to discuss what is optical fibers, what is refraction of light through prism, what is deviation of light through the prism, what is dispersion of light through the prism. This is what we are going to discuss today. We are discussing chapter number 12, Geometrical Optics, class 10 physics, right? If you remember, let me recall the previous work, what we have done yesterday. In the previous lecture, we have discussed with refraction of light, total internal reflection. We have discussed in total internal reflection, we have defined it, we have given a diagram with it, we have explained the diagram, critical angle, example of critical angle, and mathematical proof of total internal reflection, and everything related to total internal reflection we have done with last lecture. Now today we are going to discuss the new lecture, that is optical fibers. Okay, you know what is optical fibers? Optical fibers are like, they are a thin hair type glass made or plastic materials which is used in telecommunication industries to carry out the signals in form of light wave. In form of light, it is used to it can be used instead of copper wire as well. It is very cheaper than copper wire as well. It is the best alternate to transform the signal to a longer distances. Why? Because the intensity of the waves are not disturbed in the long distances using optical fibers. You know, optical fibers are very thin material, thin glass shape or rod shape materials. In form of wires they are used. Okay, look, light that can be trapped by total internal reflection inside a bent glass rod and piped along a curved path known as optical fiber. Do remember one thing, basic principle of optical fiber is total internal reflection. In optical fiber, the principle used is total internal reflection. All the light are bending inside the inside optical fiber. No light is transmitted through the boundary. Okay, why? Because critical angle is greater in that case. Okay, we are going to do that, right? Look, so we can say that light can be trapped. We can trap the light by which principle? Total internal reflection inside a bent glass rod. Like, we have a glass rod and we can trap the light inside it and piped along a curved path, and the light can move in a curved path as well. This is known as optical fiber. This is what we call optical fiber. Second definition of optical fiber is a thin hair like rod of glass having central portion of high refractive index. We have the central portion of a high refractive index, what we called core, which is surrounded by a glass layer having low refractive index, what we call cladding. Okay, then we have the outer surface, what we call jacket. Okay, let's come towards the third definition. What does it say? A thin hair like glass rod through which light propagates, means light travels by total internal reflection, called optical fiber. This is what we call optical fiber. Okay, on which principle it works? It works on the principle of total internal reflection. Let's come towards the diagram. Look, this is what we are having, a diagram of optical fiber. Look, a light ray is coming and striking this point. Again it is reflected inside, again reflected inside, again reflected inside. The outer portion is known as jacket. This inner portion known as cladding with refractive index 1.39. The lower as well, cladding 1.39 with refractive index, and central portion is known as core with refractive index 1.53. Okay, its thickness is about 1/100 millimeters, right? Okay, it is also used in telecommunication industries to carry more information than copper wire, and it is cheaper as well, so it's best alternate for transforming the signal to the light to the long distances. Okay, now through which material we made optical fibers? Plastic is used or glass is used. Okay, how it is the construction? It is basically a cylindrical shape with three regions, with three sections. The first is core, the second is cladding, the third is jacket. Okay, and you know why we use jacket? You know, it is used for the protection against moisture, against abrasion, against crushing, against environmental damages, we use jacket. Okay, then we have do remember one thing, optical fibers has a angle greater than critical angle. This is the important point. Okay, optical fiber has an angle greater than critical angle, so all the lights are reflected and no light is transmitted through the boundary. Okay, thus light maintains its intensity over a long distances, right? So this was all about optical fibers. We have done with that optical fibers. Now we are going to discuss what is refraction of light through prism. Okay, refraction of light through prism we are going to discuss. Now look, first of all we need to understand what is prism. You know, prism is a glass mad body, triangular in shape, and it has some sides rectangular as well, few sides triangular and some rectangular. Like how? Look, prism has three sides rectangular, like it has three rectangular sides and two triangular sides. I have drawn a diagram of it also. It is also available in the physics laboratory, you can see that. Okay, then we discuss how is the deviation of light through prism. You know, we are falling incident ray on prism. Prism is made up of glass. Glass is considered as a denser medium compared to air. So we are going to discuss how a change in path, how the original path is changed or deviated from the when it is passing on the prism. We know that in the previous lectures we have discussed that when light ray falls on a material medium from rare to denser, it bends towards the normal, right? So we have this rule, and on the same principle it will work as well. Look over here, this is glass prism, right? This green color is known as glass prism. Okay, now outside we have air. Air is considered as a rare medium. This glass prism is considered as a denser medium. Now what is happening over here? Look, an incident ray BC is coming and striking the prism. Done ho gaya? Okay, according to the rules the ray should follow the path CD, but in real sense due to refraction it does not follow BD path, but it does not follow BD path, it follows CE path. According to the rules, the incident ray BC should move towards CD. It should follow that path, but due to refraction it does not follow CD path, but it follows CE path. Now the incident ray is laying inside denser medium, and outside we have air, means rare medium. And we have read that when light ray enters from a rare to denser medium, medium, it bends towards the normal, and when light ray enters from a denser to rare medium, it moves away from the normal. Okay, look, inside now the incident ray CE is laying inside the denser medium. According to the rules it should follow EF path. According to the rules it should follow EF path, but in real sense due to refraction it does not follow EF path. It follows EG path, right? It follows EG path. Now what we do, this is incident ray, this is refracted ray. What we do, we stretch this EG ray back. We stretch this EG ray back. When we stretch this EG ray back, so what we observe, we see that this CD ray and EG ray, when stretched backward, they are intersecting each other at point O. They are intersecting each other at point O, and over here at point O an angle is forming. I'm talking about this angle. I'm talking about this angle. Do remember one thing, this angle is known as what? This is known as angle of deviation. This is known as what? Angle of deviation, right? So this is how we do with deviation of light through prism. Okay, what we have done, let me summarize. An incident ray BC is falling on a prism from air to glass, mean rare to denser. According to the rules it should follow CD path, but in real sense due to refraction it does not follow. It follows CE path. Now the ray is inside the denser medium and outside we have air. So according to the rules the ray should follow EF path, but in real sense due to refraction it does not follow EF path, but it follows EG path. Okay, what we have done, we have stretched the ray back. We have stretched the EG ray back and found that EG ray are intersecting with CD ray at point O. Over here, this angle is forming, this angle is known as angle of deviation. This is known as what? Angle of deviation, right? So this was all about deviation of light through prism, and now we are going to discuss what is dispersion of light through prism. What is dispersion of light through prism? First of all, we understand that what is dispersion. You know, dispersion means when light rays are falling on a material, on a certain medium, and it splits into its own basic colors. This is known as dispersion of light. Dispersion of light means when light ray is falling on a certain material, on a certain media, and splits into some basic colors. This is known as what? Dispersion of light. You know, sunlight is made up of 7 colors. When the sunlight is fallen on a prism, what does it do? It splits up. It splits up into 7 of the basic colors through which sunlight is actually made. This phenomena is known as dispersion of light. How can we say that? The phenomena in which sunlight is falling on a prism and splits into 7 of the basic colors, this phenomena is known as dispersion of light. The splitting of sunlight into 7 of the basic colors after falling on a prism, this is known as what? Dispersion of light. Okay. Now look, as a result of dispersion, we get a band of colors, right? We get a band of colors or a sequence of colors. Do remember an arrangement of colors we get, right? And that arrangement of colors is known as what? Spectrum. Okay, now look what is happening over here. Look, this is an this is a prism over here, the same physics we have discussed over there. Okay, incident ray is coming, and after that refracted ray is coming over here, right? After refraction, we get a kind of a spectrum over here, an arrangement of colors over here, a beam of colors over here consists of 7 basic colors. This was what? This was sunlight. Okay, this was what? This was sunlight, or we can say white light, both we can say. Now the colors that we obtain are red, orange, yellow, green, blue, indigo, violet. Okay, so this was all about dispersion of light through prism, right? So we have fallen a sunlight on that prism, and it is split into 7 of the basic colors. A spectrum is formed, and we have done with that ray ROYGBIV, right? So this is how we do with dispersion of light through prism, right? Let's summarize today's work, what we have done. In today's lecture, we have discussed optical fibers, which were thin, hairy like substances and of a thickness of 1/100th millimeters, right? And used in telecommunication industries, right? We have done with all these, and it has 3 sections: jacket, core, and cladding. Cladding with different cladding and core have different refractive indices values, right? So we have done with that. Okay, and then we have came towards refraction. Next topic was refraction of light through prism. Refraction of light through prism. Before going that, we understood what was prism. Prism is a kind of a glass made materials having 3 sides rectangular and 2 sides triangular, which is used to refract the light. Look what was happening over there. The ray was, incident ray was falling, it was moving to CE path and then to EG path. We have refracted the ray back, and there formed angle of deviation, right? So we have done with that. Okay, then we move towards dispersion of light through prism. In dispersion of light, we discussed that the splitting of light rays into its basic colors known as dispersion of light. Okay, when we have fallen a sunlight on a prism, and after dispersion, we got a spectrum that was containing with the 7 basic colors: red, orange, yellow, green, blue, indigo, and violet, right? So this was all about today's lecture. Today was the last lecture of first term course class 10 physics. Last lecture of first term course class 10 physics, right? So hope you have enjoyed the lecture. Thanks for watching. Allah Hafiz. Fi aman Allah.